Okay guys, starting the second stream, continuing on where we stopped in the last one, analyzing the data loading, data iterators, batch iterators. We had a super productive session. I hope I can sustain 2 more hours or a bit more of this same effort. That would be amazing. And then we can submit the results, the new eval function. So let me just put this here and then submit the new work to GitHub. And finally, this is going to be the next one. I'm going to probably focus the whole next stream just thinking about these. And again, as a short recap, in the previous video, I've basically been analyzing the whole data loading logic. Let me turn on the live chat. And here are some of the notes from that process. Okay. And then we transform, prepend. So that's called prepend. We then transform it, prepend like tokens to both, and that's this data set. And then abstraction above the two data sets, above and language directions data sets, which are of this class. Actually two, sorry. Two data sets, two source/target, which are of that class, and finally wraps up multiple of these for every length direction we are training on, and assigns a sampling ratio to them. That's kind of the logic of how it's constructed. And finally, we wrap it into the batch iterator, and that's it. Okay, guys. So let's continue iterating here. So we are now in the train step. I want to understand again in exact detail what happens here, so we can debug later in a simple way the empty dictionary issue we had during the eval function. So let's kind of see what happens here. Fix batches to CPU, set to false. Shuffle, if we have curriculum, then we might start shuffling only after a certain number of epochs. Here we don't have it, so we're going to be shuffling immediately. So let's go and let's step into this. What does this do? We're in the epoch batch iterator. If disable shuffling, then we do that. Okay, let's see what's going to happen. So if dataset epoch is true and this dataset has epoch, then we call the set epoch. Okay, this is not going to do anything interesting. We can continue here. So if callable and previous epoch different than this one, okay. Otherwise we go here, get iterator for epoch, and that's all we're going to do. So we assign it here and then we retrieve it back. So that's what the next epoch iterator does. But let's see what this one does. So get iterator for epoch, we have the epoch, we have the shuffle setting, we have the fix setting, enter here. So this one, get iterator, supports prefetching if shuffle is set to true, which it is. Then we shuffle our batches. We grab the frozen batches for some reason, these 512. No, actually we have 17,534 here. I'm not sure why. We are still trying to analyze how did we get this one. And then we shuffle them. Why do we shuffle? I'm not sure why are we shuffling. These guys, frozen batches. And then all of them have like 500. Okay, so these are just I assume these are just indices. We'll have to understand it a bit better later. Maybe we can do quickly something like, let's see what this is. This is of shape. It's a tuple actually. So what's the length of this tuple? Okay, and then let's grab the first one. Okay. What I would love to do is just understand how many of these we have. So how can we count quickly? So we can quickly count this by going for element in frozen batches, and then we can do probably element num element, and then we can just do a sum or something like that. Like this could be a counter sum, and just do this. Will this fail? Okay, numpy doesn't have. Okay, then we can just do I guess shape, and then we can do np product of the shape. This is gonna obviously fail because I have to import numpy as np, and then we have to do what? Tuple object is not callable. What is a tuple object? Let's see again. Self frozen batches. So this is of length 512 as we saw before. But what's the type of this one? Let's just see what's the type of this one. This is numpy. Okay, so that means we should be able to. It's not shape. It's not callable. That's what they were complaining about. So we have to do this, but without the shape here, and then counter. Okay, so 1602, 105. Yeah, this is precisely the indices that we built up during the loading phase. That's the number I've seen before. So now that makes sense. And so what shuffling does is basically shuffles those indices. So let's see what's going to happen. We do have a to-do to understand that frozen, the first batch, and then in parentheses, frozen batch, called internally. I'm going to figure out how we get to that one, but let's just see what shuffle does. If it's frozen, we just retrieve back the frozen one. And then here's what the shuffle does. With the numpy seed as the context manager, okay, cc numpy with specified seed. We go here, and then we just call random shuffle of all of these batches. Now the thing here is, this will not batch internally, like this will not shuffle inside of the array, only I guess across these 17,000. Let's maybe enter here quickly. I'm not sure whether we'll be able to do this. Probably not. Okay, let's just exit. This is numpy. We can't really step into this, I guess. And so we end up with just a shuffle dataset. Okay. So far so good. Let's continue. We've shuffled them, and now we wrap them into this sharded iterator. So that's where the whole magic happens, where we are now going to shard this across multiple GPUs. So I have 2 GPUs. So it's going to be sharding these indices across 2 GPUs. Okay, so we have 2 shards. This is shard ID, I guess 0. Field value is empty, and we get the batches. So let's see what this one is going to do. We can initialize it, and then it's going to have some specific initialization, but that the counting iterator is actually the interesting bit, where we'll be entering here, I guess. has next take. So this is going to be, these are some of the methods that we require. Here, let's enter here. Let's see what's going to happen. We have the length of the iterable, which is going to be, I guess, the 17,000 something. Yes. And then divide that by the number of shards. And then do the ceiling and then integer. So here's going to be the length of the one shard. Okay. One thing I also want to understand is, before I was doing this, now I just want to see, instead of sum, I want to understand just what's the individual size iterable. Is it always 512 or something? Let's see this one. It very much differs. Huh. Wait, these now look like, these look like we are like length of sentences. I'm a bit confused still about what's going on here with this, because I didn't understand how it was created. So here, 168, 96, 40. How were these created? I have no clue. But the number of them seems to be the same as the number of indices. So that's why I'm suspecting these are indices. Okay. So now what we do here is zip the longest. 01 is slice. And fill with value empty. Aha, so this might be the reason why we are returning empty. And then, as a consequence, we are failing later in our eval function. Let me see. Let me break this down. So map. What's this? Let me use ChatGPT to parse down this expression. I love using it for such use cases. I'm going to open up the ChatGPT, my old friend. Can you help me understand the following Python function? And then just do this and this. Let's see. Creating an iterator by combining and manipulating two different iterators using the map and the zip longest function. Let's go through it part by part. The first part is slice of iterable, shard ID, length, and number of shards. Create a slice of the iterable object. It starts at shard ID, which is an index within. It continues until the end with a step size of shard. So every second one, right? This essentially selects a subset from the iterable starting from shard ID and taking every. So this one creates a slice. Okay. And then range a sequence. Okay, fair enough. And then this creates a range of numbers used for pairing with a sliced iterable in the next step. Okay. And then in the zip, it's used to combine two or more iterators into tuples. In this case, it combines the range of numbers and the sliced iterable. Okay. If the two iterators are of different lengths, fill value is used to fill the missing value in the resulting tuple. So that's it, guys. So one of these might have empty element, and that's causing issue on one of the processes, on one of GPUs. I think we got to the bottom of it by just debugging, and I knew this is going to happen, by just debugging what's going on here with data loading. We understood why we're hitting that issue, but let's continue. So again, used to combine the two, combines the range of numbers and the sliced iterable, and if they are of different lengths, then this is used to fill. And finally, there's this item getter. Is a function that, when given a tuple, returns the element at the index 1 of that tuple. Let's see why that is. So that's because That's because we are here grabbing the, okay, as the function to apply to each tuple produced by the zip longest. Okay, this effectively extracts the second element of each tuple, which corresponds to the sliced iterable items. Okay. And then map applies that function to each tuple produced by this. This results in an iterator containing the second elements of the tuples produced by the zip longest. In summary, this code is used to create an iterator that selects and returns a subset of elements based on the specified. Okay, just an amazing explanation. Okay, I want to quickly just do this and see what we get. Let's assign it to temporary variable and then see what we get here is slice object. If we just did a list of this one, then we end up with this array, 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 array. What's the length of this array? Zero. Huh, okay. Let's repeat this. So again, temporary, and then convert it into a list, and then what's the length of temporary? Okay, so the length looks like this, and if we grabbed temp of 0, we get what? We get the first element, and then we get the second one, etc., etc. Okay. If any values, Now the confusing part is, let me just think, sharded length is this. What's the original size of the iterable? So it is divisible by 2, so here we won't have the issue, but I think for the validation set we might have the issue, because, well, we'll certainly have the issue because we have 997, right? So that means we're gonna have one of them will have empty slice, but how does that not ruin, like ruin the computation in validation function? That's, I guess, the interesting part. Just lower my shaders. Okay, maybe a bit more light, otherwise I'm gonna be like a vampire. Okay. So again, let me try and understand this. We fetch from the iterable a subset, and then we fill in a value if there is any one that's missing, and it's not, so we don't fill it in, right? So at the end, even if we took like temporary of -1, it's still gonna give us a value. Otherwise, okay, so let's go here, hit F5. So we have an iterator. If we create a list, then this one looks like this, and that's it. So we basically just have one after another, we have these indices, these arrays, okay? And then we call the init with that iterator and start being set to get the attribute from interval n, if not return 0. Let's see. Okay, we return 0, so start is going to be at 0, and total is going to be sharded length. Okay, let's enter into the init quickly. That's the parent. Again, iterable, convert it into an iterable, n equals to 0, and then we here get 8,000 something, right? Okay, if it's not none, return total. Okay, we're done there. So effectively what we've done there is we took the batches and we converted them into a sharded version. And then we return self. And then why are we here? Just a second. Because we called the list on top of that one. Let's see. We are here, length. Next. Why are we calling the next one? Not sure, maybe the list is causing that. Ah, okay. Yeah, we failed because I was playing with it a bit too much. So I depleted the iterator. Okay, it doesn't matter. I'm gonna just disable everything and rerun it. Let's rerun it. See what happens. Okay, here we are. Oh my god. Okay, enter here. Now we're back. We're back here. Ignore all of this. Let's go here. Shuffle batches. We've done all of this. We've done all of this. We were here. Let's quickly go here. Let's exit. Let's just first enable all breakpoints. Self, length. Get the next one from the iterator. And the next one equals is the first one, and then we increment this by 1. Return the value, same here. Return the value, same here, return the value. Okay, let's exit from this one. And we end up here. And that's it. Okay, now this worked. If number of workers bigger than 0, we set some warning. And then we call the data loader with the data set, which is our sampled multi-data set, with a collate function. And that collate function was from that data set. And then we also pass in batches with the offset, batch sampler, number of workers, etc., etc. Okay, so we additionally wrap it up into this. So what happened? We started here. We called in here. And then everything fun happened in this function. We've shuffled. We've done the shuffling and sharding. So basically, when we call this, later, this one calls a shuffle on the data, plus it also does the sharding across GPUs. started iterator. Okay. We are done there. And then we additionally wrap that into this one, counting iterator. Okay, grabs the data loader. So now it kicked off the second process. So let's just continue. It just kicked off the second process, and we are back here. So here we are. Start, this should be 0, and total, this should be around 8,000 again. So why do we have this one additionally? I'm not sure why. Probably just to keep, to maintain the iteration count. That's all it does. So on the next, it fetches the next one. And just adds +1. And make sure we have the next one. Let's see whether take is ever called or skip. But this is the ultimate one. So at the end, that's then wrapped into a counting iterator. Okay. Let's continue. Where are we? Why are we here again? Wait, main. Here we are. Init. Let's continue. That's it. Skip reminder. Get the number of batches. So here's where we grab the take. Is a lazy implementation which discards the final batch regardless of whether it's a full batch or not. So take will go to the counting, find the minimum, and then later, okay, then later we'll just report that the last batch does not exist. Okay, that's it. Shuffle, return this back, and we're done. So now just, let's see, this is just some configs. This should be 1 because we don't do the grouped iterator. This one additionally does gradient accumulation. And then we wrap the iterator into progress bar. If that was not enough, we additionally wrap it up into the progress bar. It's going to be JSON, which is going to be wrapped into weights and biases. So there's going to be wrapper upon wrapper upon wrapper. So I think I'm going to place a breakpoint into each one of them. Just going to be interesting to step through all the way down to the lowest levels. Okay, let's go here. Get item. Why do we call the get item in the language pair? Because because we are here, and the second one is there. Okay, we just got this one was kicked off. Second process, second GPU, so that's what's happening here. Okay, let's hit F5 to get here. Update config. What it does is grabs the config, blah blah blah. Delete some stuff. Okay, it just modifies the config, doesn't matter. And then begin epoch. Does what? learning rate, updates the learning rate, and calls the begin epoch here, which is just a no op. And that's it. Okay, here's where the fun stuff starts. This is where we're gonna enter everything from so let's see what's gonna be the stack. So, and finally that's wrapped up in a progress bar. Okay. So we're gonna step into, depending on the process, one of them will skip weights and bias. If it's not a master process on the GPU, we're gonna skip this one. Either way, we're gonna go to JSON, then to counting iterator, then to sharded one, and then is that one wrapping up the epoch one? Did it actually wrap it up, or we stopped there? Let me just quickly go up there. Okay, we're gonna see it in a second. Let's hit F11. So we're in the JSON progress bar. We grab the length. This is the length of the iterable. So now let's step into it. So we are now in the counting iterator. So iterator and called next. This one called the next. So we are here. If it doesn't have next, which is basically decided by n and by the size, and then we call the next of this iterator, which is basically the sharded one, I think, or whatnot. Let's see. No, actually, this is the data loader from PyTorch. So that's what it was wrapping. So this one calls a shuffle on the data. Wraps it into PyTorch data loader. Okay, so we are now here in the PyTorch data loader. I have to quickly just remind myself of this. What happened here exactly? So let's just see. Epoch iterator is epoch batch iterator. Let's just find that one. And then let's find among iterators, let's find next epoch iterator. Oh my god, I keep on losing the files. This is just terrible. Wait, where is my file? Why do I have all of this opened up? I don't need you. I don't need you. I just need this. Find this one. Okay, this one is not implemented. Oof. I've lost the thread. I'm gonna stop this. I have to understand what exactly happened there. Here, where do we enter? What's this one? Let's rerun the train. We have to understand this exactly. Disable all except for this one. Run. So we have to just clarify a bit more this part here. And let me find progress while we're waiting. Okay, we're still already there. Let's enter. So we are epoch batch iterator. We are here. I'm not sure why I found the one that said so epoch batch iterator here, epoch batch iterator. Okay, and so inside of here we were calling this one, and inside of there we were for shuffling the batches that we got from the frozen batches, which comes from the epoch, that comes from this, from epoch batch iterator. We grab the batches, we shuffle them here. So again, let me just write that down. Later calls shuffle on the frozen batches from epoch iterator, plus does the sharding. Let's see how it does it. So it does the sharding by wrapping the batches into sharded iterator. Okay, does the sharding across GPUs. In the shuffled batch into this. Finally, we take the batches and we pass it into the data loader. Okay. This is a keyword as well from this. Does sharding by doing this and then this. Okay. Now we're good, and now that this is here, we wrap it up into the counting iterator. That's it. Let's now go back here, put a breakpoint here, and let's continue. This is the second process. Let's wait until we hit this breakpoint. Here we are. Let's go. First step, JSON bar. If we went with the other process, if we took the other process, this is going to step into weights and biases first. Weights and biases. Grabs the length. Here it is. And now we go into JSON bar. And now we go into counting iterator. And now, after this, we go into counting iterator next. We grab the next piece of data. The next piece of data comes from the data loader. Okay? So data loader calls the next data. And this one grabs some information. We are now inside of PyTorch. We get the data. We get the data by doing what? Try and get the data. Get a slice of data. And here is the final data. Why do we get only 2, and why don't we step into just a second? So we shuffled it, we sharded it, and then we passed it into the loader. But we still have to call the collate function. Just a second. So we still have to call the collate function of this guy. Let's go and find that class. Here it is. We still need to go to the collate. Where is the collator? Here it is. because if we exit here, if we take a look at how we wrap this into the PyTorch data loader by looking for next epoch iterator class, next epoch iterator, we wrapped it up by passing in the data set. The data set is this sampled multi data set. We pass the collate function and the batches. So that still means we have to call the custom collate function, which comes from this data set. Because these batches here were just, if you remember, just these indices. So we missed that step somewhere. We're gonna see what happened. Because here this returns the data, processes the data by doing, try to put the index, whatever this does, get the next index. Gets the data, returns back the data. Counting iterator, we are back to counting iterator. We increment by 1, we fetched a single batch, and then we go up, and then we're in JSON bar, and then we are in weights and biases bar, and then we're here. Okay, but we missed a single piece, so let's see. Will we ever call the get next from this one? Let's see, class. We go here, the data set. Get virtual init. Will we able to call the get item from this one? I don't know. Likely not, because we have passed in the batches. I don't know, but we'll see. Okay. Hit F5. Okay, we do hit the collator. We do hit the collator somewhere. So in this one, in the main thread, we're now here. And in the second one, we are running. Weird. This is just weird. Where does that step happen? I'm trying to understand where is that missing link. Okay, let's stop everything. Just stop the program. Disable all breakpoints. Just go to the train. Again, put the breakpoint here. And let's wait until we get here, and then I put the breakpoints on the right places first, and then we're gonna enter. You thought your code base is complicated. It's not that hard, honestly. I'm already getting the hang of it after only a couple of weeks. Okay, so before we go here, I want to do the following thing. Epoch batch iterator. Let's find its function called next. Oops. Called next epoch iterator. which is gonna be here. And so here we are. We passed in the batches, the data set. We know what's the data set. The data set is the sampled multi-data set. So let's go there. Let's quickly go there and make sure we have set the breakpoint on the right location, which is the get item. Maybe one length, maybe one collator. Maybe even prefetch. And well, while we are here, let's maybe see whether any of these are actually hit. When we start entering. Okay. Okay, that's one. Next up, let's go. And so that's the data set. Collate function. Self-collate function of this one is called here. So if we go to train, if we go to load checkpoint, we called the get train iterator in the trainer, and we built the iterator, and the collate function that we passed in was what? We had the data set. I'm fairly sure that we grabbed these data sets. But let's find the task. What's our task? It's how can we now find the task quickly? When one easy thing is to just stop everything and rerun it again. Or we might be, let's just find this one. I'm running the wrong file. I have to call the train. I swear to God, I'm going to understand every single detail of this code. Okay, here we are. Hit F5, enter. Translation multi-simple epoch task. Let me just mark down that name. Okay. Where are we? We are here. Where is the, so we have the data set here, this one, let's put a breakpoint there. That's the batch sampler. And let's now see, so dataset collator, as you can see. So sampled multi-datasets collator is used as a collate function for the epoch batch iterator. So that means we have to go to this collator. Well, not that one, but this one. Let's go there. Collator, as I said, this is the right collator, and I have a breakpoint there. Okay. So now I'm gonna hit F5, and We're gonna start running this. Did we already go through this? Wait, frozen. Nice. So, okay, that was the missing link. I wasn't sure what's going on with how we were getting these initial ones. So now we're gonna answer that question as well. So, yeah, I'm not sure what's the English proverb, but like 2 flies with 1 hit or something like that. Or 2, I forgot what's the proverb. Solving 2 problems by the same approach, by a single method. Let's understand this. So we are here, and I was trying to understand what's the missing link. Something was skipping. And then all of a sudden, interesting. To get the length of the frozen, so that was the thing. We went to the first batch, we went inside, and then I didn't step into the length. My God. Because the length kicked off a call to here, because this is self.frozen batches, and because this is none, because this is none, we called the batch sampler on the dataset, oh my God, with the epoch, and then the batch sampler is this one, because this was the batch sampler we passed during the construction. Here, batch sampler. So that's kind of the whole link. So now let's understand what's going on. This is going to be the interesting part. Okay. So we go through this dataset. These are the data sets. We're in the translation multi-simple epoch task. And the data sets are, okay, we have various different data sets. We have these length pair ones. We have the concat one, and we have the sample multi. There's multiple of them here. So what we do is we go through items, and we get the S, which is the key, and if that data set equals this one, which is the sampled multi, only in that case do we store that split. Okay, let's go. So that means we're gonna just remain with the train split, just the train split. And now if length is bigger than 0, we just grab the 0th one. So here is that split. Okay. Now we call the data set epoch, which does nothing as usually, and then returns start time, start batch sampler memory usage. Okay, we enter here, and then we call the datasets ordered indices. Let's go inside there. So if shuffle set to true, we do permutation on the length of self. Oh my God. Let me just think for a second. When we were doing the init in this data set, what did we do other than, so here was the init, reset, setup sampling, that helped us get the virtual size and sample ratios, and then we called the set epoch, which helped us establish the virtual data sets, which basically helped us get these indices and whatnot. So bunch of logging here, bunch of logging, but we got the virtual sizes and the indices, and these indices were just shuffled, I think. Indices, we stacked them, and we got them by random choice as well. So now again we are permuting them. Let's see, what does this do? Length, virtual size. So this is our virtual size of the whole data set. Let's go further. Okay, so we just get the permutation. And then what is this? Aha, these are the wait, why do we have this one? Remind me what the sizes are. How did we get this one? Let me just recall that fact. Sampled sizes. Why do we have two? Wait. What's the trick there? Okay. Yeah. 2016, 36. Those are. I see my audio. Okay, my OBS disconnected for a second. Hopefully you can still hear me. Let me know if you have any issues. Self sizes. Why do we have these numbers? These look to be like the sizes of the sentences. Aha. Okay, guys. Yeah. Because we have source and target, right? So those are the source and targets for our virtual dataset, which combines Turkish English and Hindi English. Okay, let's go. So sizes. And then target sizes is this, and source sizes is this. If it's not none, we go and do what? We do a random permutation of the sizes, because indices were chosen by a random permutation, and then we sort them, and then we pick those indices. Aha, sort by target length, then source length. So what does the sort do? Got it. So sort by the target length, then source length. So we grab our sizes, we extract the indices. Why would we do this? Why would we take a random permutation before sorting? Why not just pass in the sizes? Unless, yeah, that's weird. And then we sort using merge sort. And then I guess that will retrieve back the indices. So retrieve back the indices such that they're okay. And then we do again source length for the sort indices. Okay, so those are the ordered ones. Let's exit. Okay, so that's what we do here. We grab the ordered list of indices, and then we start iterating through that list. There's going to be a single iteration. Memory usage. Get the time. Filter indices by size. So we filter out examples that are too big. We started with 1.6 million. And now we filter. We pass in the data set, the indices, the max positions, and ignore, yes, ignore. Okay, so we enter here. Filter them by size. Get the target sizes. Get the source sizes. We find the ones which are bigger, so we ignore them. And there is only a couple of them. Actually one. And so we filter them out. Ignored. We grab we grab these ones. As long as they are smaller and these are smaller, we pick them up. Okay, so there is a ton of stuff that happens in the background, guys, as you can see. Filtering and ordering of indices. Sort indices by target and source sample sizes, and then we filter out the ones that are too long, over 512. That's kind of the whole process. Summarized, distilled. Are these the indices that we were already sorting? Let me just quickly check that. So we ordered them, and then we took the ordered ones, we passed them in. So if they're ordered, why is it that the long one was found here if we have 1 million point something? If you know what I mean. If this is sorted by length, why is that long index in the middle of this whole thing? It probably comes from the source sizes. Let's see. If we just do this and we sum, this is 1. If we do this, then we sum, This is 0. So it actually comes from target. Interesting. So because we first sort by the target and then we sort by the source length. Let's see. So pick them out. Okay, so we start from 6 and now it's going to be 5 length. 6 and now it's 5. So we filtered out that one. That was too long. Yes, today I'm debugging, not debugging, I'm just analyzing the whole data process. Like, it's been a super fun session this morning, like really learned a ton. Okay, and now we return back the indices. We filter them by length. We filter out the ones that are too long. Okay. Let's continue. And then we have batch sampler, batch by size. And then a ton of log statements, just some appending there. And then we retrieve back this one. So this is where the rest of the magic happens. We have this sampled multi-data. We have the indices which are sorted and filtered. Max tokens, max sentences, required batch. Okay, let's see what this one does. Batch by size. This one is actually from Fairsec, which is the parent class. So get the batch shapes, just none. In that case, number of tokens vector for this one. I have no idea what this is. Let's see, let's step into it. We grab the sizes and we take the indices. And we end up with this. And then we do what? Max across all dimensions, but the first one. So that does what? So we find the maximum across each of the source target lengths. We find the max, and then what? So this now gives us some numbers. Okay. Some of them are super. So they start from 3. So we obviously sort by. Got it. So the initial ones are only of length 3. And then we continue. Okay. And then batch by size. So indices. Not sure what number of tokens does, but we're gonna see soon. Number of tokens, and then this number of tokens in the vector, max number of tokens, max sentences. Let's enter here. This is now Fairsec data batch by size. -1 required. Okay, we are now here. Batch by size, indices, vectors, max tokens. Let's enter here. Max dispatcher. Wrap reduction. What? How did we end up here? Batch by size. Where is this one passed in? Data utils fast. Let's find this one. And this is called what? Batch by size back. Okay, this is some by X format. Which we cannot debug really. So that's why we ended up here. And then rep reduction, whatever this is, guys, we are in deep. I told you this is going to be a deep debugging session. This is okay, we're now in NumPy. Let's just run from here. Let's run from NumPy. Let's run away from NumPy. Okay, let's go back. And that's it. We have a batch sampler. And that's how we end up with these indices. So now these are sorted such that we have first the short ones. Okay, that all makes sense. Let me quickly recap here what we've seen. We ordered them. We picked them up here. We filtered them. And then we ordered them by size. And then we additionally chunked them. We chunked them such that none of them are bigger than. So here are the indices, here are the max. None of them can be bigger than 2048. That's how it works. So if now we pick maybe, we should expect the first ones to be bigger, right? This one should be bigger, shape 512, because I guess a lot of them is of short length. 408, 408, 336. Okay, it's again increasing. 512. 336, 224, 72, roughly seems to be decreasing. 16, 17,000, and we have, what's the length? The length 17,534, 533, super short. And this is out of index, okay. It seems it's mostly going down. With some variations, we saw one of them was bigger than the previous ones, which is weird. So the reason that happened is we filtered them such that the first batches are going to be a lot of sentences, but very short. That's it. There is this weirdness that I don't understand. Why did we have this non-monotonic increase? 512. So we have 512 sentences here because all of them are short and that they satisfy that they are below 2048. And then it keeps going down, but at one point it again goes up. Let's see let's just continue this sequence. So if we were 4 with shape, and 3 was this, okay. And then let's go 5. So it goes down, and then 6, it goes down, and then 7, it goes down, and it goes down, and then 9, it goes up. Okay, and let's see 10, let's see 11, 12, 13, 14, 19. Okay, we started going down. We started going down there. Let's see when did that start? At 14. Let's go here. Again, it's going down. Going down. Going down. Going up. So it's definitely not monotonic, at least not in the way I'm expecting it to be. So that's my hypothesis there is violated. So these indices should be such that this particular data set, can we index into this data set? Can I do just like data set of like 0? Yes, I can. Okay, let's then see. Let's quickly test these indices. Let's quickly test the indices, because I don't see why would this work like this. Indices. Let's see the first 10 of them. Okay, let's now pick some of these numbers. Let me just do this. Take the indices. These are supposed to be the shortest sentences. Let me just put it somewhere, just for debugging purposes. So these are supposed to be the shortest ones, right? That's how we sorted indices. And then let's now validate that. Let's grab the data set, grab the first index, grab we have the target and we have the source. So let's grab the source. Let's actually first grab this is tuple. So we go like this, we go like 1, and then let's go like source. So here it is, very short. And target, very short as well. Okay, so far so good. So then let's grab one of the next ones. This one should be of the same length roughly. Yes. And then let's grab indices a bit later. So if we grab something from like maybe 500 to 510, so now these should be a bit longer. Still not. Okay, let's go to like 1,500 to here. Let's pick them up. Still not. Okay, let's go indices 5,000 to here. And then let's pick them up. This is longer, but still only 4. Interesting. Aha, because indices are super. They're like, okay, we have to go a bit more than this. Let's just add 5 here. So now let's pick up these indices. These are now longer. 50,000. Yes. And finally, if we go super crazy, indices length is like 1,000,006. Let's go to 1.6 million. Something like this. And then that same number here, and then 10, or like this. Okay, and now let's go and print these. These should be super long. Yes. Shape of this is 153, and then target 223. Okay. So indices definitely is arranged in such a way, but then batch by size was for some reason returned back batches which are not really reasonable. So if we go here, batch by size, because it's actually from the parent class, batch by size is here. Return batches according to max tokens, max sentences, and required batch size multiple. So this is 1048, this is none, and this is 8. So we saw before that, adjust batch sizes. Let's see. No, we skipped this. We didn't go there. We went here. We found the longest. We found the longest source target. Here. And that's how we arrange them. So then we passed indices, number of tokens, this one, max tokens, max sentence, required batch size multiple, fixed shapes, and then we call this one. And then we got these numbers, indices, and then we finally call this weird function from there. Interesting. Okay. I'm gonna just write a note that this did not make complete sense. So line 354 in construct batch sampler func in translation multi simple epoch task. Didn't make complete sense how the final indices were batched. Doesn't seem to be monotonic in size. Just to leave a note to myself. I mean, it might be very complicated in the sense. Well, one could do an analysis here. One could do an analysis here, like pick up these indices, pick their source and targets, and see the distribution. Just visualize this a bit. Okay. And now we append that and we're done. We're done. We're done. We call the chain on this one, which is just a list. And we retrieve that back. And now we have the frozen batches. And now we call the collate. Okay. And so frozen batches from 0. A lot of them are going to be super short. So now I remember. Yeah, so this should be basically, yeah, I did analyze this before, so we can skip this. We can now remove this. And this. Let's just exit here. Let's exit from the collator. And finally, we set the dummy batch to be equal to that 0th batch. And we're done there. Okay. Now, going back, you're really required to have a good memory to analyze code like this. That's one of the conclusions for sure. We can remove all of this. What we wanted was in the train. We started by analyzing train step. And we wanted to analyze how it looks like to step into this. So again, I'm going to now disable everything. Stop this. Put a breakpoint here. Run train. Run this. Let me just remove some notes because we now understand how this frozen works. First batch, frozen batch internally. How I couldn't cut. I cut this one out. I think I understand why this happens because we have an uneven number of samples in the Flores. Likely because of uneven number of samples in Flores. 200. Oops. Come on, stop. Combined with sharding. Almost there. Almost there. I'm gonna add this task of understanding exactly what happened as a research to-do task for anybody who's willing to take it on over the next days. It's more for our understanding of the local code base of Fairsec. Okay, now that we're here, let's go and put the breakpoint to collate function. So we have to go to, oops, wait. Notion is causing me issues there. Okay, let's just go here, find the collator function. We can actually just turn on all of the breakpoints. Just enable everything, including collator. And get item. Everything there should be enabled, that's fine. And there is one more thing other than collator. We passed in the batches and the data set, right? Just a second. Here it is. So we passed in the data set, collate function, and batches. So that effectively means we have to just be sure that we have enabled a lot of breakpoints across this class. And we did. And we did. So that's it. Let's go back to the line. And finally, let's start stepping into this. I'm going to write up a doc about how the data loading works using this stuff I wrote here. Okay, those are just the future tasks. Now we just want to debug this and submit the work. And then we can go and start accumulating those tasks. F1, F11, let's enter. Here we are. We're in the counting iterator. Okay. Iterator. Next. We go here, and this calls basically the data loader from PyTorch. Next data. Okay. Let's go. Get the data. Try to get the data. Try to get the data. And we are where? We're here. Aha. This might be a blocking call. So we now triggered the second. We've triggered the second length, that's also internal length. Okay. So this is the second process. Next data. Break. Enter here. Get data. Go here. Try and get the data. And skipped. We got some data. And I could not enter. Why didn't we hit any of the functions in the sampled multi? There's some lingering yellow line here as a potential signal something went wrong there. So data, length of this is 5. Net input, source tokens. Let's just grab this data 1, net input, source tokens, shape. Okay, we fetched 5628. Okay, 5628. I see it's ending with 2. Was 2 end of source, end of sentence token? And if so, where did we add it exactly? Where do we add the end of sentence token? Okay, there is still stuff I have to understand, but for now this is good. So this was success, we return the data. Process the data. Could PyTorch be any more intuitive, any less intuitive? Try put index. Try put index. Next index. In the data loader, calling the sampler iterator, which is just some list iterator. What's going on in this code, man? Okay. Let's go up here, data, data. And that's it. It just retrieves us back the data. That's one of these. Yields, 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 and we are here. Okay. And then we can fetch the second process. See where it stopped. It tries to get the data again. Timeout is, probably because of the timeout. Again. Let's grab this one again. So that's what's going on. This one is paused on a breakpoint. We are in the sampled multi. Nice. We have an index. We go here, we retrieve back some data. Index. And there, and then if we enter here, and we just fetch the data, source and target, example, and we retrieve it back. So this is inside of the torch. Possibly batch data. Let's go here. We can remove this quickly. We can remove this as well. And then we call the collate. So that's how it happens here. we have this batched indices, which came from somewhere. And then we just do the same thing as for the frozen batch logic when we are constructing the epoch iterator. And now the collate will do the same thing. So now we're in the collate and we've done this already. So we can actually ignore this and ignore this and ignore this and go back. Data fetcher. Fetch with the index. And the index came from R. And R came from, oh my god, it's a mess. Worker loop. And then data queue. So that's how we get the data queue. So this is happening asynchronously by these workers. That's why it's so hard to debug, I guess. Got it. Got it. Let's just exit. Remove this. Remove this. Remove this. Exit. Okay. Let's just disable all of the breakpoints and just exit this. Exit. And that's it. That was the train step. Okay, that was crazy. That was actually legit crazy. I'm gonna stop this. I definitely have a better understanding of what's going on. There is still a lot of complexity that popped up when we were loading the data with PyTorch data loader. But I think now we have enough to just wrap up these tasks. Okay. Like, I'm curious, where is the sentence, end of sentence added? Okay. Let's answer the question. Only loaded data for shard 0. Why? Okay, this is another question. There's a ton of questions, but this is the one that we need to wrap up the work to submit it. Trying to understand why we return empty at one of the iterations. So I guess the question is, when we are in train, there is uneven number of samples for the uneven number of samples for Flores 200. As a consequence, when we're sharding across two devices, one of them will have basically an empty sample, and that messes up our eval function. My question now is, why is that not messing up the rest of the code? What guards do they have in place to prevent such same issues? So if we go to validate, they also have the iterator here. So here's the progress bar, here's the iterator. All of this remains the same. And then they are iterating here. And they ask if, so this might be empty at one of them, at one of the loops. So when we enter valid step, prepare sample, could it be the prepare sample might skip something? Or let's see, could prepare sample do that? If sample is dummy, if sample is none, or the length of the sample is 0, then okay, that's their defense. The prepare sample function is their defense. That's it. So assert that dummy batch is not none. And then what we do is we prepare a sample that's going to be a dummy sample. Okay, guys, this is how they do it. And this is what the dummy batch is for as well. I was not sure why the dummy batch is being created in the first place. But now we have the answer. So we keep on learning more and more here. Let me just see. Dummy batch, when we go here, load checkpoint, and then create get the train iterator from the trainer, reset dummy batch. Dummy batch is set to batch, which is the first frozen batch. First batch. Okay. And the first batch comes from this one. From the frozen batch of 0. Okay. Having said that, again, let's go back to validate. And save. Let's go here. Let's go to validate. Prepare sample. Let's just find the prepare sample. Let's remove all of the breakpoints, disable all of them. Valid step again, as I said, and here is the prepare sample. And as I said, in the prepare sample is where they fix all of that. So sample, valid sample, valid step, and here. Put a breakpoint there, run train. That's how we're gonna solve our bug. Oh man, I learned a ton today. Just like the all gather, like just dealing with these edge cases here. Very, very fun learning experience, honestly. This is gonna be fun. Okay, let's wait until we hit that line. Where are we? I think we're running train. Here we are. Let's enter here. If it's dummy or if it's none. So one of them is going to be none. Let's see which one. on one of the processes, just because we have uneven number of samples. So let's wait while this wraps up, and we're gonna certainly hit one of them is gonna be none. Non-existent, which is represented by an empty list, as we saw in the sharded iterator. Okay. Let's see. Let's see what's going on Discord. Let's wait. A bit of breathing exercises. This was a tough one. Still a couple of questions to answer. There are two parts to training neural networks: understanding data and understanding distributed computation of a neural network. And then there is a whole set of dark magic to understand why your loss is spiking or any instability you might have. So I'm kind of lying, but this is a first good step. Okay, here one of my GPU is running like crazy. Okay, let's see. Waiting. We should hit it somewhere near the end at one point. And here we are. My predictions are correct. One of the samples is empty, actually represented by an empty dictionary on this level, but somewhere down the stack I saw it represented as an empty list. Doesn't even matter. Okay, so we assert that we have dummy batch, and then we call prepare the sample with the dummy batch. So what does that do? That calls this one with the dummy batch, and the dummy batch comes from the trainer. Dummy batch, let me just see. None. Reset the dummy batch. When was this called? I know that we call it for the epoch iterator. I didn't know we call it here. And then if it's dummy, then we set it to sample here in the prepare sample. Okay. Let's go. Let's see where we stopped. We stopped here. And then, so we grab this basically dummy batch, we convert it, we move it to CUDA, I think here. We move it to CUDA, we convert it, and then we return sample false, and then we just return that one instead of the failed one. But now why would we do that? That's gonna mess up things. And then we just continue and do the step with this dummy sample, which is actually just a dummy sample, as they said. So I think it might be just more elegant to skip it. So again, instead of grabbing a random dummy batch information, better to just skip that step. I'm not sure why they do it like this. And then they do the step with that one. Okay. So, okay, that makes sense. I'm gonna stop this. Stop this, stop all this. Disable all array points except for this one. Let's just see where this one is created. It's probably gonna be created. Is it for validation or? Not sure, but we'll find soon enough. I mean, we can also call prepare sample ourselves if we want. Okay, let's see. Load checkpoint. Aha. Okay, so that was the dummy batch actually came as the 0th batch here. So that's weird because like during the validation they pick a random sample from training actually as a dummy batch. That's completely unnatural behavior. So that's what I do here. They literally set this one to be equal to this, and then this is gonna be 512 sentences. Okay, I'm not sure why they do this. Let's hit F5. Let's hit F5, so that's for both processes. Hence 2 times hitting F5. And now this will not happen anymore. Or it will. So during validate and save, aha! During validate and save, once we are over with this, we call again reset dummy batch. Which does what? Is it again grabbing just the first batch? So should be the same information, right? If we go here, if we open this one up, just a second, if we open this one up, net input, source tokens, file 512.3, and here also net input, source tokens, 512.3, and the numbers are 2560471898080. Is this the same one? One. Okay, nothing there happened. This is just some, if it gets changed for some reason, then they do it. That's when they call the reset. Same for the second process. And now they run again. Okay, so every now and then they'll be running this in the validate and save. Just to make sure we always keep the first batch as a dummy batch. Because apparently sometimes they set it to like maybe a string or something. Let me see. This equals. Yeah, I'm not sure where it's changing, but okay. Enough. Disable all breakpoints. Go to our code. I'm now confident this is not incorrect. From my side, anything. So if the length of sample is 0, we can just skip this particular step because we care about sampling, and so we don't want to pass in this particular line. What I'm curious about maybe as the last thing is if we go to the generate script, how was that handled in the generate script? So sample, here's the progress. So we have this patch iterator again, blah, blah, blah. Let's see. Buffer size, next epoch iterator, shuffle false, don't shuffle. And then, okay, here we didn't do the sharding. That's why it was handled. But let's see how they handle it. So sample, just move to CUDA. They don't have any checks here, as if they always expect this to work for some reason. What if we have sharding? They do support sharding. Yeah, I'm not sure what will happen there. Maybe there is a bug, who knows. But I'm certain that this now is a legit way to handle stuff. Let's go to validate step. Let's go to validate here. Validate step. Prepare sample. So if the sample is none or length is 0, then instead of doing this, we're just gonna skip it. Because of sharding and the fact that the data set can be of uneven size or odd size, we need discard. And that, guys, is a final implementation of everything we need to do sampling during training and on the Flores, and also do Sacred Blue CHRF computation. This is just amazing stuff. Let me see the tasks. Go back here. Almost done. Trying to say why we return empty, and I understood it. And now I need to submit the work. And then start adding tasks and maybe understand this one last thing before we can do training. We're just loading data from shard 0. I need to understand where is the 27 leftover shards for Turkish English. Let's first just submit this so that people can play with this if they want. So let's navigate to one of these files. Copy path, clear this, so change directory to here, and then git status, zoom this in a bit. What should we submit? Let's see, let's start with the temporary file. What is this? Okay, this is just some, as the word suggests, just a temporary file. I've been creating those every now and then to just quickly test stuff. And now they're just junk lying around. Okay, YAML custom eval. Do I want to do custom eval? I don't think I need it because we have it here. So custom eval. This is mostly just something we can delete because, let me see. We mostly do this now during training, so we don't really even need it. So we can just delete this. Custom eval can be safely deleted. Let's go on. What else do we have? YAML test sacred blue.py in the evaluation. Test sacred blue. We again, this was more of a temporary thing where I just debugged quickly this sacred blue code. And then, so I added it to the Python path and then imported the main, and then I was just running stuff. So we don't definitely need to, oops, we don't need to submit that for others. There was a weird bug there. I was really struggling with relative imports, so that was a good learning as well. YAML zip, calculate custom calculate metrics. What is this one? Custom calculate metrics. What did I do there? Again, I was just playing a bit with this code, which we don't need anymore. Just delete this. We're good there. Okay. Slowly cleaning everything here. Now, git ignore. There is now a ton of files here. Let's see. Fairsec train, of course, that's going to be the biggie. Git ignore. What did I submit here? Just a second. What did I change in git ignore? I added model checkpoints here. Let me see whether we can make it a bit cleaner. Model checkpoints. Is there any mention of a model in general? Nope. So data. Where do we call model checkpoints in general? Where do I hard code that? Nothing. Only my. I'm lying. In my getting started, launch JSON. Yes, it's kind of assumed that that's where the checkpoints lie in. So I think this is a legit change. We can leave this as it is. Nobody wants to submit model checkpoints accidentally. So we can add git ignore. Let's go. Analyze data. What did I change there? Quickly going back to analyze data. Looking at the changes. This was just some local stuff I was running with Serbian Cyrillic, so we can actually discard those changes. Let me just close down the diff visualization, and so just go git check out this particular file. We don't need it. Whoops. Copy and then paste. And then download parallel corpora. What did I do there? Just commenting out stuff and calling download with different data. We don't need that as well. We can check out that code just to revert back the changes. Calculate metrics. What's that? Calculate metrics. What did I do there? Okay, we again don't need this. Let's just go git checkout and then remove this. YAML, generate multi. What did I do there? Okay, this is a local. This is just a local hack. I don't like this one. I don't like this one. So let's add this as a task. I'm gonna have this set locally, this local change kept here, but we need to add this as a task. So somebody has to go and understand it's another task. Understand how to avoid the Hydra error in generate multi pipe. I have a local fix. I'm gonna leave that one as it is because I have a fix there, but I'm not gonna submit it either. So that was the generate multi, then all bunch of YAML files, and then we have this config spy file. Config spy file. I've changed something here as well. Yeah, we can revert this back. This was just some pipeline parallelism exploration. So we can just revert that back as well. Revert back the configs file. And we're left with just training. So all of these can be left as they are. We just need to submit training. And that's the last thing. So let's find the train.py. Let's see all the changes I made. Pickle, am I using pickle here? I commented it out. This should not be submitted. We need this because of this. We need chrf, prst. I'm just trying to sort it alphabetically. We need weights and biases here as well. And then comes the whole function, this giant function that does this thing. And then comes the logic here. Okay, and it's gonna be done with the same frequency as validation. So every time we do validation, you're gonna do this as well. It kind of assumes that you have weights and biases installed, stuff like that. Let's quickly see whether this is clean enough to be submitted. Oh, we'll also need to submit the intermediate translate. This YAML will be needed. Okay, we need that one. Almost forgot to commit it. Custom YAML, we don't need that one. That's just for me. Train, default. Everything else looks good. Okay. So we'll load that one. We convert this to eval. Generations. Can I clean this up a bit? So we go through the languages. Increase the readability a bit. Let me just. Okay, I don't respect the vertical line. Yes. Language code. One of these expects it. We have to set it up. We build the generator, the iteration, just a simple progress bar, and then we go and sample. Log the progress, move this to the inference, and then for each of the sentences in the batch, do all of this. Revert back to the original state. With a dynamic way of setting max size. This is more of a we could dynamically okay, and then post-process all the other results. Basic checks, stop the running time, and then log to weights and biases. Step 1. Log the corpus CHRF ++ score. For each of the lang directions. Step 2, grab 20 random samples and log to weights and biases. And log in a form of a table. So again, we just create the metric, get the random indices, we go grab those, compute the sentence scores, store that, save the table, and finally add this. And that is it, guys. That is it. Quickly run the trainer once. We see what I messed up here. To do restore to 12. Let's leave it at 6 for now. And restore to 1000. Let's leave it because of testing. Let's now run the train and let me show you the results, guys. Let me show you the results. I'm gonna run this after we disable all the breakpoints. Hit run. While it's running, I'm gonna go just grab a short break, and the stream is also almost over. I'm almost done with the stream. Let me just put the break like a note, short 3-minute break. Be right back. See you soon, guys. Okay, I'm back. Let's see. Let me show you the results, guys. Open up the link to our weights and biases dashboard. And let's wait a bit more to just report all of this. I guess it still didn't even finish the first one. It's still running. We're gonna see there until that's being computed. Let's just see the tasks. So now I'm gonna submit this work, and then I'm gonna add some tasks to the GitHub project, and it's gonna be in the next session. And I also take some time to understand some data loading. So there is a ton of cool stuff to analyze and do. So yeah. I have to check out how to find the best Serbian public bytext as well. I have some context. Some people reached out to help out around this, so that's going to be cool. I'd love to train a very good Serbian English or something like that, bilingual model. Building up the muscles here for training various machine translation systems and understanding data from various different regions and languages. That's the goal. Let's submit the work, and let me then I'm gonna do this. As the next steps. Something like this. This is going to be the task for those who are brave enough to attempt them, to tackle them. And this is the description of how this works. I'm going to make a nice document out of this. Let me just wrap up this. I'm going to submit this latest change, and let's see whether we have the data logged. We should have it logged by now. Let's just hit F5. Here it is. We have eval. It's currently just a single dot. We have sample data here. Currently just gibberish. But ultimately it's going to be very, very, very useful. I'm going to stop this. And let's submit the code. So add train. Potentially, we can add a flag for that piece of code. Do we want to add a flag? And what are the assumptions, by the way? The assumptions are, I don't think there are many other than weights and biases. Intermediate, I don't think there are any other than weights and biases. So this is going to be fine. This is going to be fine. Everybody's going to have this. I checked it in. This is fine. This is fine. Even for FSDP or not FSDP, all of that will work. Well, this is an assumption that I'm making. We're using different, same SPM, same source and target dictionaries. That's one assumption. And then the other assumption is, well, the second assumption is we are running machine translation tasks because this is FairSec and they kind of made it for everything. We're now kind of shoehorning it into our own use case. Other than that, let me see. I don't anticipate anything else here. Maybe we hit this issue, too much memory, but I doubt it again. This is kind of the upper threshold, upper limit that we'll ever hit. It's gonna go just below this afterwards. Generations, again, nothing there. And here we assume that you have installed weights and biases and Sacred Blue. That's pretty much it. I think it's good for now. Let's submit it. That's it. We are golden. Close this down. We're getting more and more stars. I didn't really market this project that much yet. That's cool. So here it is. Last commit here. I'm not sure why I'm not noticing any activity here, even though I'm contributing every day. Why is this the case? Why is it not updating it? Maybe I'm not logged in or whatnot. No idea. I'm gonna check it later. Okay, guys, this is it for this stream. We'll continue after the break and see you in roughly 2 hours. I think 8:30 p.m. CET is going to be the next one. Cheers, guys. See you later.